Good morning, students. I'm very happy to meet you all after a very long time, and I know you are eagerly waiting for this session. So let us enter into our session. The first topic of our textbook is nothing but rational numbers. So you already learned in our 7th standard about rational numbers, and before to going that, we are going to see some basic numbers, that is type of numbers. So already you know these type of numbers in our earlier classes. So type of numbers. So in that first one is nothing but whole numbers. Already know about the whole numbers. That is, the whole numbers are start from 0 onwards and which contain only positive integers. You already know about the number line. On the number line from 0 onwards and right of 0, it's keep going on. They are positive numbers and also they are known as whole numbers. And secondly, natural numbers. So natural numbers nothing but just a part of a whole number except 0. So in whole number that includes 0 with the positive integers, but here in natural number only the positive integers without 0. So they are called natural numbers. And there is no negative integers also there. And the next third type of numbers, integers. That integers contain all type of numbers. So they are negative integers and also positive integers including 0. So that is your number line. So in this number line, that left of 0 is nothing but negative integers and right of 0 is nothing but positive integers. And what about 0? So 0 is neither positive nor negative. Already we know that. So this set of numbers are known as integers. So that is the representation of integer line. Now another type of numbers is there, that is rational number. That also our topic. So what is rational number? In our earlier classes, that is in our 7th standard, you already know about that. That is, the rational numbers are in the form of p by q. That is, p and q are integers and the denominator is not equal to 0 always. So integers means that p and q are contain either positive or negative numbers. Now we are going to see some example for rational numbers. So 3 by 4, 5 by 2, minus 2 by 5 and 7 by minus 3, etc. So rational numbers are keep going on like this. So the first two are known as positive rational numbers and the second two are known as negative rational numbers. And you may be having one doubt, that is, what about fraction? You already know about the fraction in your earlier classes. The fraction also these type of format only, isn't it? So 3 by 4, can we call 3 by 4 as a fraction? Yes, it's a fraction. And also what about 5 by 2? So that also a fraction. But not 2 by minus 2 by 5 and not 7 by minus 3, because a fraction which contains only positive integers. So the difference between fraction and rational numbers is nothing but the fraction which contains only positive integers in its numerator and also denominator, but rational number which contain negative numbers also, as in our previous example. So that is the difference between fraction and rational numbers. So these are everything, the basic thing only. Now your chapter which contain 2 sections. One is nothing but properties and another one is nothing but about rational numbers and operations on rational numbers. So the first topic, now we are going to see the first topic, that is first section of your lesson, that is properties. So before to go into that, I am going to ask some questions to you. So look at the first question. Is 0 a rational number? So if you want to check whether a given number is a rational number or not, it is enough to check or it is enough to compare that particular number with your definition. So recall the definition of the rational number. What is rational number? A rational number is in the form of p by q, where the numerator and denominator, that is p and q, are integers. So and also q not equal to 0. That is the definition of the rational numbers. Can we write 0 as like this: 0 by 5, 0 by 2, 0 by 3 and 0 by 1000, 0 by 10,000, whatever it is, the value is nothing but 0 only. So the numerator 0, is it an integer or not? Yes, 0 is an integer only. And what about the denominator 5? So that also integer. And if you take 0 by 100, the 0 is an integer and 100 also integer. So whether it satisfies the definition of the rational number or not? Yes, it satisfies the definition of the rational number. Therefore, 0 is a rational number only. And what about whole numbers? What is whole number first? Start from 0 onwards and which contain everything positive numbers. It is positive integers. So let us take any one example for whole number. Take 5. Can we write 5 as 5 by 1? Yes. Can we write 6 as 6 by 1? Yes. Can we write 1000 as 1000 by 1? Yes. So every whole number can be written in the form of denominator with 1. That is 1 by 1, 2 by 1, 3 by 1, like that. So the numerator and the denominator are integers, because already we know that whole numbers are rational numbers only. So here 2 by 1 also, 2 and 1 are integers. So it is in the form of p by q, and your numerator and denominator are integers. Therefore we can call whole numbers as rational numbers. In the similar way, can we call natural numbers as a rational number? Yes, because natural number is a part of a whole number, isn't it? Except 0. So whole numbers start from 0 onwards with the positive integers, but natural numbers starting from 1 onwards except 0. So except 0, that is 0 is already a rational number, and we have seen the secondary other positive integers also a rational number. Therefore natural number is also a rational number. So 0 can be written as 0 by anything, therefore it is a rational number. And whole numbers, everything can be represented with the denominator 1, therefore that also a rational number. And natural numbers also defined by like this. So these everything are under rational numbers. Right. Next, these are some examples of rational numbers. We can take 0.75 also, that is decimal numbers. Some of the decimal numbers only not comes under the rational numbers. So that you will study in your higher studies. And 8 by 4, 4 by 8, 0.5. So the decimal number with the terminated form, everything comes under rational number. So these are the several examples for the rational numbers. Right. Next, we are going to see the properties of the rational numbers. So that is our first section of your lesson. So already you know about the properties. Yes, in your 6th standard and 7th standard, in both classes, you have seen or you have come across some list of properties. Shall we recall the properties now? Yes. So first one, closure. So second one, commutative. Third one, associative. Fourth one, identity element. And fifth one, inverse element. So these are the special properties. These are the special properties, and you have seen these kind of properties in your lower sections also. In your 7th standard, you have seen the properties and you have verified these properties on integers. Now we are going to do the same thing but on rational numbers. Now we are going to verify all the rational numbers whether they satisfy these kind of properties or not. That is your first section. So that's it. Now we are going to see one by one, right? So closure. So what is closure? That is, closure is nothing but if you take any two numbers and if you operate that numbers, operate means you can either add or subtract or multiply or divide, whatever it is, the result will be the same kind of number. So then that will satisfy closure property. The definition is nothing but if A and B are any two rational numbers, because we are going to verify the closure property on rational numbers only, not on integers, not on whole numbers, and not on natural numbers. We are going to verify on rational numbers only. So let me take two numbers, that is A and B, both are rational numbers. Then that A star B also a rational number. That is, we are going to check the result of A star B whether it is a rational number or not. That's it. Right? So if you want to check the closure property for rational numbers, it is enough to choose any two rational numbers and operate them and check the result. If the result is also the form of a rational number, means then the rational numbers satisfy closure property. We can say like that. Here the star I already said, that is the operation, that is we are going to operate two numbers A and B. So in between the two numbers, the star stands for any operator, that is addition, subtraction or multiplication or division. Now we are going to see one example. So look at here 1 by 2 and 5 by 2. Let us take that 1 by 2 as A and this 5 by 2 as B. Now look at here, if you want to verify the closure property, we need two rational numbers A and B, right? So that here we took 1 by 2 as A and 5 by 2 as B. If you operate this, that means if you add these two, first we are going to check with the addition. We are going to check 1 by 1 operator. So first I took addition. So 1 by 2 plus 5 by 2, the result is 6 by 2. What is 6 by 2 now? Is it rational number or not? Yes, rational number only, because 6 is an integer, 2 is also an integer. Therefore, the form of 6 by 2 is nothing but rational number. So if we add two rational numbers, the result also a rational number. Therefore, the addition satisfies closure property. So that is the conclusion. Now we are going to check with another operation, that is minus. Look at 7 by 3. Is it a rational number or not? Yes, rational number. What about 2 by 3? That also a rational number. If you subtract these two rational numbers, our result will be a rational number, that is 5 by 3. Is it a rational number or not? Yes, 5 by 3 is a rational number only, because 5 is an integer, 3 is an integer, and 3 is not equal to 0. Therefore, it satisfies the definition of a rational number. Therefore, the result is a rational number. So, if you subtract 7 by 3, that is, if you subtract any two rational number, the result also a rational number. Then consider another operator, that is multiplication. Look at 9 by 2. Is it a rational number or not? Yes. And what about 5 by 6? That also a rational number. If you multiply two rational numbers, what about the result? 45 by 12. Is it a rational number or not? Yes, rational number only. Therefore, if you multiply two rational numbers, the result also a rational number. Now, we are going to check the finally with the division. So, 4 by 3 a rational number, 2 by 9 is a rational number. If we divide these two, so how can we divide two rational numbers? What is the procedure? So, first we have to write the first number, and instead of division, we can take multiplication symbol, and we can take the reciprocal of the second number. So, the 2 by 9 can be written as 9 by 2. So, 4 into 9, 36, 3 into 2, 6. So, the result 36 by 6 is also a rational number. So, if we divide two rational numbers, the result also a rational number. So, what is the conclusion here now? Rational numbers satisfy closure property under addition, subtraction, multiplication and division. So, that is the conclusion. So, in example, that addition satisfies rational number and subtraction satisfies rational number and multiplication and division also satisfy a rational number. So that we come across this conclusion. Right. What about the next topic? That is, what about the next property? Commutative. So that is the next property. So what is commutative? So commutative is nothing but interchanging the numbers. That means, look at the definition. If A and B are any two rational numbers, then A star B equal to B star A. As I already told, A and B are any two rational numbers. So if we operate the rational numbers as A star B and look at the result and operate B star A, that means exchange their places. So B star A. Now look at the results. If they are same, means that rational number satisfies commutative property. So that is the result. Now we can see some examples. Now we are going to check under addition, right? What is 4 by 7? A rational number. What is 5 by 7? Another rational number. If we add these two rational numbers, what about the result? 9 by 7. So now we are going to check in another way, that is